Welcome. Today, we're exploring the role of humidity in aseptic processing environments. I'm Dr. S.K. Singh, and together we'll uncover why controlling moisture levels is critical for maintaining sterile conditions. This topic is key for anyone involved in cleanroom design, pharmaceutical manufacturing, or quality assurance. Let's dive in. Let's start by looking at the typical environmental conditions in aseptic processing. Temperature usually sits between 18 and 22 degrees Celsius, while relative humidity ranges from 40 to 60%. Now, relative humidity is the amount of water vapor in the air compared to the maximum it can hold at that temperature. It's a crucial factor because it influences everything from microbial contamination to how particles move through the air. It also affects static electricity, product stability, equipment function, and even how comfortable the team feels. These conditions help keep the environment controlled and safe. When it comes to regulatory expectations, there are a few key points we need to keep in mind. The EU's GMP Annex 1 calls for strict control of environmental parameters, with continuous monitoring when it's justified, all tied into a broader contamination control strategy. The FDA's CGMP emphasizes that environmental conditions must never harm product quality. Meanwhile, WHO and PIC-S GMP standards require controlled manufacturing environments, qualified HVAC systems, and solid environmental monitoring programs. Across the board, humidity limits should be backed by science, considering the product, the process, and contamination risks. Humidity plays a crucial role in contamination control, affecting both viable and non-viable contaminants. It influences bacterial survival, fungal growth, and how long microbes persist in the environment. On the non-viable side, humidity impacts airborne particles, electrostatic attraction, and material shedding. It also directly affects product quality, from moisture uptake to stability, and even container closure integrity. For example, an aseptic filling line running at 70% relative humidity saw more microbial recoveries and condensation issues, highlighting just how important humidity control really is. Let's look at what happens when humidity gets too high, specifically above 60% relative humidity. In this example, normal levels were around 45%, but an excursion pushed that up to 72%. Before the spike, microbial counts were almost zero. After, they jumped to 6 to 8 colony-forming units. That's a big increase. Excessive humidity creates the perfect conditions for microbes to survive and thrive. We see mold, fungi, biofilms, and even condensation forming. Common culprits include Aspergillus, Penicillium, Bacillus, and Staphylococcus species. Because of this, a full microbial investigation was launched. Let's talk about condensation, a major risk in aseptic processing. When warm, humid air meets a cooler surface, moisture forms. This water can accumulate, creating a perfect environment for microbes to grow. That leads to surface contamination and a loss of aseptic conditions. For example, in a room at 21 degrees Celsius with 75% humidity, a cold surface at 15 degrees can develop visible condensate. Regulators, like EU GMP Annex 1, flag this as a serious contamination risk that must be controlled. Let's talk about what happens when humidity drops below 30%. Low humidity leads to static electricity building up on surfaces. This causes electrostatic discharges, which in turn attract particles. The result? More airborne particles floating around, higher risks of contaminating products, and even equipment glitches. For example, at just 25% humidity, the particle count jumped from 3,000 to 8,000 per cubic meter, all because static made particles shed into the air. It's a chain reaction we need to manage carefully. Humidity plays a crucial role in product quality, especially for moisture-sensitive items. These include lyophilized injectables, sterile powders, biologics, and vaccines. When exposed to high humidity, risks like hydrolysis, potency loss, and stability failure increase, along with container closure degradation. For example, a sterile antibiotic powder exposed to 70% relative humidity during filling showed moisture uptake, a drop in assay value, and ultimately stability failure. This batch then underwent a thorough quality impact assessment to understand the full effects. Let's talk about humidity and environmental monitoring, two crucial parts of keeping controlled spaces safe and efficient. We use continuous monitoring with humidity sensors linked to building management and SCADA systems. This setup tracks relative humidity, temperature, particle counts, and even microbial levels. For example, in a Grade B area, relative humidity is checked every minute. If it hits 50%, an alert sounds. If it reaches 55%, action is taken immediately. This constant vigilance helps maintain the right conditions, preventing problems before they start. Let's look at the actions we're taking to manage risk. We start with a product impact assessment, understanding how changes affect what we make. Then, we investigate any deviations from our standards. Additional environmental monitoring sampling helps us catch issues early. Finally, we implement corrective and preventive actions, or CAPA, to fix problems and stop them from happening again. Here's an example risk scenario. Our specification calls for relative humidity around 45%, plus or minus 5. But an event pushed it up to 68% for 5 hours. That's a high-risk situation across several factors, from product exposure to condensation potential. This assessment guides how we respond. When it comes to controlling humidity, there are 3 key areas we focus on: engineering, monitoring, and operational controls. Engineering controls include HVAC systems, dehumidifiers, humidifiers, and HEPA filtration, all designed to manage the environment actively. Monitoring controls involve continuous relative humidity tracking, alarm systems, and data trending to catch issues early. Operational controls cover things like controlled door openings, preventive maintenance, and routine calibration. Together, these strategies can make a huge difference, like reducing humidity excursions by 90% over a year with automated control. Let's break down the key lessons about humidity control. When humidity drops below 30%, static builds up, and particles become more of a problem. On the other hand, keeping humidity between 40 and 60% helps control contamination, keeps product quality steady, and makes the workspace more comfortable for operators. But if humidity climbs above 60%, microbes survive longer, condensation forms, and the risk of product damage goes up. Meeting regulatory expectations means having qualified HVAC systems, continuous monitoring, and strong controls based on risk. We also need to investigate any deviations, track trends, and ensure data integrity throughout. Humidity plays a vital role in aseptic processing environments. It's not just about comfort, it directly impacts contamination control, product quality, and equipment performance. Keeping humidity within well-defined, scientifically supported limits helps reduce microbial growth and limits particle generation from static electricity. This is essential for maintaining sterile conditions and meeting strict regulatory standards. By integrating effective humidity control into contamination control strategies, supported by strong HVAC systems and continuous monitoring, we ensure reliable, compliant, and safe pharmaceutical manufacturing every step of the way. Thanks for joining me today. If you want to explore this further or have any questions, please don't hesitate to reach out. I appreciate your time and attention, and I look forward to continuing the conversation. Thank you. This video was created with SlideSpeak. Visit SlideSpeak to turn your presentations into engaging AI-narrated videos.